Good day, budget-wise audiophiles. As you know, my name is Joe, the founder of Fidelto, and today I am showing you all the test results that I've accumulated over the last week, and then what this means in the real world. So let's go. First of all, the test scenario. It is 50 watts into a 12 ohm load. The frequency sweep will go from 10 Hz to 100 kHz. Then I will show you a 10 kHz sine wave, 10 kHz square wave, and triangle wave. And then at the end, a fast Fourier transform analysis. So the first thing will be the frequency sweep. Let's look at the setup. So the first thing is the oscilloscope, of course. We have a wave generator, which generates the frequency sweep. Then we have two inputs. The first input connects to the input of the amplifier. And then the second probe will connect to the output of the amplifier. And that's how it will calculate and show us the graph of the frequency response analysis. Then the start frequency, as I said, is 10 Hz. Stop frequency is 100 kHz. We have a 680 millivolt peak-to-peak amplitude, and that then will equal to the right output to output 50 watts into the 12 ohm load. And then the output load of the oscilloscope is high impedance, so high Z, and that simulates basically what a music player would be, and it takes 60 points per frequency. So let's look at the analysis. So as you can see, the blue line shows us the gain, and the gain is 30 decibels, basically constant across the board, so that's very good for the audio. And then we have the red line, and the red line shows us our phase angle, and as you can see here at 20 Hz, because we care about 20 Hz to 20 kilohertz. At 20 Hz, it is a little high for my liking, so that's what I'm going to be working on to get this lower. And then at 20 kilohertz, it's not very bad, and that's acceptable. So basically, if we could just flip this over to here and have that same phase angle shift at 20 kilohertz, then we would be very good. And that's what I'm going to be working on in the next week to get that down to here. As you can see, it's very flat across the audio spectrum. And that's very important because we want our music to sound very good. So this is already a very good sign of the amp. It has a very constant gain, and the phase angle shift is also very acceptable in this audio space. Then let's look at the sine wave. So at the top you can see the input. The input, it looks fuzzy, so you may see here and here, but it's actually very clean, which you can see from the green line, and that's just because it's a low voltage, so the oscilloscope has a little bit of noise that's being added. But it's a clean output signal. And as you can see, 24.5 volts peak to peak in the output, and 840 millivolts input. And that means that's the 30 decibels gains that we were just talking about. And it looks very good. There's no crossover distortion and no weird oscillations that you may see on bad designed amplifiers. Then let's look at the square wave. So square wave, again, it looks very good. There's no oscillation. As I said, again, in bad oscilloscopes, you would see oscillation here or oscillation here. And then if we zoom in, we also don't see any oscillations at the points where we transition from low to high. The slew rate is also acceptable. And if it was a digital signal, I would not say that this is good, but for audio, this is very respectable again. Then let's go to the triangle wave analysis, and that also looks very clean. No weird oscillations at the transitions, and just overall a very clean signal. Then let's look at the FFT analysis. That shows us here is our fundamental, and it looks, if we look across the board and we look at all the harmonics are very low. And that's what we want in an audio amplifier. We don't want to have very high harmonics, which will distort our audio. We just have a very clean signal. So this is all the data that I've accumulated over the last week. It isn't very much, but I want to share more data when I receive it. And then I will also share that. So let me switch this over. I hope you enjoyed, and I hope that you have now seen that really the amp is a high quality, correctly priced amplifier, which is going to change the audio market. Thank you very much for watching. And when I have more data, I'll make a new video and then you will see more info. I'll probably be planning a video with an 8 ohm and 4 ohm, not probably, I'm going to make a video with an 8 and a 4 ohm load at full power. And then we will also look at those distortion data, at that distortion data. But this was just a quick test, 12 ohms, 50 watts, and the data is very promising. So thank you very much for watching, and I will see you in the next video. Bye guys.